strong base using universal indicator. Our aim here to study the pH changes during the titration of a strong base with a strong acid. Theory. The solution of strong base sodium hydroxide due to higher concentration of hydroxyl ions has higher pH. As acid is added, the pH of the solution decreases, which changes the color of universal indicator, which has a wide range of pH from 4 to 11. To perform this experiment, the apparatus required are a burette, stand, 10 ml pipette, conical flask, beaker, funnel, and white glazed tile. The chemicals required are 0.1 molar hydrochloric acid, 0.1 molar sodium hydroxide, and universal indicator. Let us perform the experiment. Wash the burette, pipette, and conical flask with water. Rinse the burette with 0.1 molar hydrochloric acid solution. Using a funnel, fill the burette with hydrochloric acid solution. Remove air bubbles from the burette and adjust the lower meniscus of the solution to the 0 mark. Keep a white porcelain tile below the burette. Rinse the pipette with 0.1 molar sodium hydroxide solution. Pipette out 10 cm cube of the sodium hydroxide solution into a clean conical flask. Add 2 to 3 drops of universal indicator. Shake well. Observe the color of the solution. The color of the solution is violet. pH of the solution is 13. Now, prepare the observation table as shown. Add hydrochloric acid drop-wise from the burette while swirling the conical flask. The color changes to indigo. Note down the burette reading. It is 8.3 centimeter cube. Note this in the observation and result table. Continue adding hydrochloric acid drop-wise from the burette. The color changes to blue. Note down the burette reading. It is 8.6 centimeter cube. Note this in the observation and result table. Continue adding hydrochloric acid drop-wise from the burette. The color changes to green. Note down the burette reading. It is 8.9 centimeter cube. Note this in the observation and result table. Continue adding hydrochloric acid drop-wise from the burette. The color changes to yellow. Note down the burette reading. It is 9.2 centimeter cube. Note this in the observation and result table. Continue adding hydrochloric acid drop-wise from the burette. The color changes to orange. Note down the burette reading. It is 9.7 centimeter cube. Note this in the observation and result table. Continue adding hydrochloric acid drop-wise from the burette. The color changes to red. Note down the burette reading. It is 9.8 centimeter cube. Note this in the observation and result table. On comparing these colors with the standard pH color chart, we can say pH of the indigo colored solution is 12 and is basic in nature. pH of the blue colored solution is 10 and is basic in nature. pH of the green colored solution is 7 and is neutral in nature. pH of the yellow colored solution is 5 and is acidic in nature. pH of the orange colored solution is 3 and is acidic in nature. pH of the red colored solution is 1 and is acidic in nature. Precautions to be taken. The solution from the burette should be added very slowly and carefully. The solution in the flask should be swirled after each addition of the burette solution. Conclusion. The pH of the solution goes on decreasing on addition of hydrochloric acid. The different concentration of hydrogen ions give different colors with universal indicator.